I am Mudita, and welcome back to Satisfactory. I have been working towards my final power plan of the save for the last few videos. It started in the swamp with more aluminum and a pressure conversion cube factory. I created another factory in the eastern dune forest to make more caterium ingots and silica. Then I moved out to the dune desert and created 50 singularity cells. Turns out I don't actually need that many, but hey, I'm sure I can find a use for those. In the last video, I created a factory to take care of most of the secondary parts I need for this new power plant. Today, I'll be combining all of these parts to make all three types of fuel rods. This is going to turn 1200 uranium into over 260,000 megawatts of power with zero waste. We're starting off in my creative save so that I can go over the diagram real quickly. I've got my three distinct rows, green, blue, and yellow, and this is how the layout for the factory of each different floor is going to go. Uranium's going to go on the bottom, we'll do plutonium in the middle, and then we'll top it off with fixonium at the top, which works out well because, in my opinion, the quantum encoder really deserves to at least have an open roof of some sort. And if you've never built one, you'll see why. I just mentioned that in the last video I made a factory to make all of the secondary parts. That is pretty much everything that is going to be in white. So the concrete, sulfuric acid, electromagnetic control rods, encased industrial beams, all of those are built in the last video. There are two, however, that I haven't built yet. And when we get to that part, I'll make sure to highlight those. But today, all of these machines are going to need to get built. Thankfully, this first floor is just these blenders and manufacturers. At 100%, I would need 24 blenders and 30 manufacturers. With power shards, I'm going to bring that down to 12 each just to keep things just nice and simple. I could use less blenders. I could get away with only using 10, but being able to use the exact same amount, so just one machine leads into the next, is really my preferred way to do pretty much all my factories when I can. One thing to keep in mind is for my setup, the sulfuric acid is actually going to be coming into the factory packaged, but I think that's plenty easy to deal with. The first floor will create 12 uranium fuel rods. At 100%, this would need 60 nuclear power plants, but if I fully overclock it, I can bring that down to 24. The only downside is that means each one of these needs exactly 600 water per minute, which is not my favorite thing to do. But if I can keep this system as simple as possible, I have faith I can get this to work out. That 600 waste is then going to come back into the factory, and we start the recycling process. This obviously has more steps than the first one, but I actually don't need that many machines. I'm going to need 6 blenders, 3 particle accelerators, 9 assemblers, and 6 manufacturers. Thankfully, not a huge amount of machines. However, particle accelerators are just gigantic, so it is going to take up quite a bit of space. The 600 uranium waste is going to get split 3/4 is going to go to the non-fissile uranium, and then 1/4 goes to the plutonium pellets. The nitric acid is one of those parts that I haven't created yet, and I'm going to have to create in the factory. But to create nitric acid, all I need is nitrogen gas, water, and iron plates. And the amount of iron plates I need, I did already automate in that factory ahead of time. So I'll already have the iron plates here. In total, I'll need 720 nitrogen gas. Unfortunately, it doesn't fit in one pipe, but still, 2 pipes, really pretty easy to work with. This step also has a byproduct of water. But thankfully, that water right there is going to end up being really convenient for me. This is where I'll combine more of the concrete, heat sink, steel beam, and electromagnetic control rods that I've already made in the previous factory. And that will create a whopping 3 plutonium fuel rods, which will generate another 75,000 megawatts of power. This needs half the amount of nuclear power plants. So instead of 30, with power shards, I can bring it down to 12. It'll also generate 30 plutonium waste. That will come back to the factory, go up to the top floor, and this is where we'll make our fixonium. 30 out of the 50 singularity cells that I'm making in the Dune Desert are going to come here. I need 600 dark matter residue, but thankfully half of it is going to come from this next step, which will produce a byproduct of 300 dark matter residue. And in the last factory, I'm manufacturing the missing 300. That brings us to this step where I need the 300 excited photonic matter, and that is the other part that I haven't manufactured yet. Thankfully, excited photonic matter is basically just turning energy into this plasma gas thing, whatever these end products are called. They behave like a gas, but they're not a gas, or something. I combine that with the trigons and the other electromagnetic control rods that I already have automated, and that will produce my 30 fixonium fuel rods, which will only produce 37,500 megawatts, but I end up with 0 waste, which I'm just a big fan of. I like just not ever having to worry about it. Like I said in the last video, I could easily create a blueprint for storage and spam a whole bunch of those down in the corner of the map, and I would never run out of space. But I think doing this whole project is just fun. It's a very involved project, but the reward is you get a whole bunch of energy, no waste, and with the load balancing, I can actually keep the radiation down by quite a bit. I should be able to make it so none of the machines have all that much radioactive material in it at once. This is one of those projects where even people who tend to only use manifolds will at least consider doing some load balancing, especially with this project where you're dealing with some pretty crazy amounts. Especially for the actual power plants, manifolding the 3 plutonium fuel rods would take absolutely forever for that to get up and running. So if anything, definitely recommend load balancing the actual power plants. It will drastically speed up your startup time. In total, this will generate 262,500 megawatts of power. And for those of you that have been around a while or have watched some of my older videos, this is quite a bit less than I made in my last playthrough. Don't get me wrong, generating over 1,000,000 megawatts was just cool. Seeing the big number is just very satisfying, let's be honest. But on some level, it also feels kind of wasteful. To generate that much power, I needed to use mainly alternates. And when you do that, it makes the whole thing a little bit more complex, and you end up needing a whole lot more of those secondary parts. I believe you would end up using a whole lot more aluminum and a lot more SAM. There is definitely something to be said for just never having to worry about power ever again, because you just have so much. But since I don't have plans to use all of that power, it does kind of feel like a waste in parts. I could be sinking those parts and get more trophies. I mean, my first golden nut is lonely. Clearly, I need a second one. Let's jump into the real save and start building this factory. Back in the real save. So off in the distance there, I'm making the singularity cells. This is the factory that got built in the last video. So it's providing pretty much all of these extra parts that are all just coming right over here and being sunk. Now, one really weird thing that I didn't notice until after I finished the video, when I tested out the sulfuric acid, this container was completely full, which would have been, I think, 4,800 canisters. But for some reason, I only got 4,794. Not really sure where those 6 canisters went, but I'm sure the system isn't just randomly eating canisters, so I think it'll be fine. I just thought that was really strange. But between those almost 4,800 and the extra 3,700 I have here, that should be plenty for this entire system. This is the location of the fuel rod factory. So let me go ahead and get this first floor of foundations down, which I think means I'm probably going to want to move these sinks to the outside, just so I have room to work with inside here. The area down here with the miners and the industrial storage containers is going to be a logistics area, and so I'm going to build right above that, but I don't think I need to build it so tall that I can fit these sinks in here. And now I've got a giant slab of concrete to work with. Even though I make and upload a good amount of concrete, having 720 concrete a minute just being sunk right here is pretty handy. And now I just have an extra supply of concrete because building this many foundations actually goes through my supply pretty quickly. It's only ever when I'm just spamming down a whole bunch of blueprints that I run out. On this floor, I need the 12 blenders for the encased uranium cells, 12 manufacturers for the uranium fuel rods. The first step would be the blenders, so let's go ahead and take a look at this recipe. The encased uranium cell, I need the raw uranium, which will be one of the last things I bring in, concrete I already have made, and then the sulfuric acid. But it's also going to give me a byproduct of sulfuric acid. Now with overclocking, these are each going to be at exactly 200%. So these are the numbers that I'm going to be working with for each blender. 100 uranium, so that's a nice convenient number. 30 concrete, 80 sulfuric acid. However, I have the byproduct of 20. So in total, this machine, if I loop back this, would only need 60. And so obviously, I had to make a blueprint. So we've got the blender and we've got a packager. So let's go through this. Like you just said, the encased uranium cell is overclocked to 200%. And then the packager is going to unpackage sulfuric acid. And for all of these, I can just leave them at 100% because it'll intake 60 packaged sulfuric acid. I'll get my 60 sulfuric acid and the 60 empty canisters back. And that's how much this is missing. Like we did with the aluminum, we want to make sure that the byproduct is the one that's prioritized over any extra amount. Even though the two numbers should add up, it's best to make sure that the blender can always empty that output, and that way it never backs up. Because if it does back up, then it stops, and then things just start crashing. So we've got the output sulfuric acid come along here. It plugs into a pipeline junction, but it's rotated vertically. And by doing this, it'll prioritize this pipe over this pipe. That means even if I let this packager back up completely and its buffer was completely full, no matter what, this machine should be able to get rid of all of its output sulfuric acid. And if you're wondering why in the world did I set it all up like this, it's just so that I would still be able to do all of my load balancing conveniently. Each different input comes in at a different height. That way that I can do all my load balancing, no clipping belts or anything like that. The uranium will come in at the bottom, then concrete, and then the sulfuric acid. Because it was going to be easiest to put the sulfuric acid up above so that I could get this whole pipe thing to work. The packaged sulfuric acid will come into here. The empty canister will then get output down to here. And then I'm going to be able to group up all of these in a line. So all of the output canisters will get grouped up and then go back downstairs to complete their loop. And that's why this belt had to go up and over, because all of those are going to get strung together. And because I have the space, I went ahead and just laid down the beam, and so when I snap them together, it'll be real easy to just kind of line them all up. And each one of these blueprints will just take up 4 foundations. Alright, so as far as spacing goes, I think 2.5 probably sounds about right. I may have to adjust it a little bit. And then I think if I give myself, 3 foundations should be plenty. And for whatever reason, even with the beam there, I still have to nudge it. It doesn't include it all the way. And then I end up with about 3 foundations on this side. Terrific. Alright, there's the first half of the blenders. So now let's go ahead and switch over to the manufacturers. Normally I would try to line up the machines with each other, but what I really want to do is line up this output with one of these inputs so I can just make it a straight belt. So let's do that one. Give everything plenty of space. Yeah, it looks good. And now I'll just alternate all the different blueprints that I have here. And I think I'm just going to keep lining it up so that the third input is the one that plugs in here. And as far as these recipes, I'm going to be using the uranium fuel rod, just the good old standard. Loaded up with power shards. 12 across 12 machines. Even I can do that math. That is completely overclocked to 250%. Each machine will output 1. This way, each machine requires 50 encased uranium cells. Just gonna have to redo a bunch of these, I think. So 50 can go just straight into there. Now that I have 6 of each machine, obviously the load balancing is super convenient, because even though I have splitters in front of all of these, what I'm actually gonna do is just delete the very end ones. But now this can just plug straight into there. That'll stretch. Perfect. That stretches. And same with that one. And then I'll do the same thing with this one. And now it's balanced across the 3. And now I can just grab one of each color splitter here. And I've got plenty of space, so we'll just pull it all the way out to here. Grab the concrete one. And the sulfuric acid. And then that'll be able to split the incoming amounts into the 2 halves of the 3. Obviously just do the same thing for the 2 remaining inputs, because we'll already have the encased uranium cell. Now I just have to load balance the encased industrial beams and the electromagnetic control rods. But pretty easy. That'll just be at the 2nd and 3rd height for those, so that they can avoid all of those belts. And then I do it all over again. That's pretty basic stuff. Let me show you what it looks like. And now it has most of the belting done. I still need to do one more set of splitters in the very center. So for all of this stuff, I think it's going to come up through, I'm not sure exactly where, probably somewhere around here. But we'll have the 3 splitters, and that way it can go to this half, the other amount go to this half. And then I'm going to have to do the same thing for the manufacturers, but because I have so much space around here, I'm just going to do those on the opposite side. I'll have 2 splitters on this side. And obviously we got to like skip the very bottom one. There we go. And so 1 half will go this way and plug into these 2 splitters. And then the other half will go this way and plug in and feed these 6 manufacturers. And this right here is enough to generate the 150,000 megawatts of power. Not too shabby. Unfortunately, you get 600 uranium waste per minute with it. So that brings us to the next floor. Plutonium fuel rods. Like I went over in the diagram, this basically has 4 steps. And the first 2 steps are kind of tied to each other because I need to split the uranium waste 3/4 to the very first one, but 1/4 of it goes to the second step. This first step is in a blender. The non-fissile uranium. These will be overclocked to 200%, so instead of 12, I only need 6. Uranium waste, that's going to be coming from the power plants. This is where the mysterious silica that I brought in the last video but never used. I just put it on a train, brought over a specific amount, and then just started sinking it. This is where the silica goes. Sulfuric acid is coming from, let's just call it the basement. And then the nitric acid, one of the parts I haven't dealt with. But here's the key. It needs 30. This is going to output the non-fissile uranium that I need, and 30 water. These 2 numbers are the same. So there's a number of different ways you could go about this, but this is the way I decided to do it. Which is obviously with a blueprint. Ta-da! It got a little bit busier than the first one that I did. We've got the first step, just like I showed. A very similar setup for the sulfuric acid, but since this doesn't have the byproduct of the sulfuric acid, I got to just drop it straight down. But I like the way that this kind of worked. And I think the way that I set up the empty packages to get out of here, I think it all just works together pretty well. Normally, I like to just overclock everything as much as I can, and then that way I use the least amount of machines as possible. There are times where this is just, in my opinion, a way better solution. I would much rather split up the belts, and that way I can keep the sulfuric acid in its packaged form much longer. And then this is the only pipe I have to worry about. Just one really short section, one machine to one other machine. I really can't think of a more reliable setup than this. Alright, so for the byproduct water, that 30 water is then going to go into a fluid buffer. And I know you may be thinking that is a really weird choice, because you certainly don't need it. The only reason I have the fluid buffer here is for the startup, because that 30 water is going to feed into a blender. The nitric acid recipe at 100% will take in 100 nitrogen gas, that 30 water, and 10 iron plates and create the 30 nitric acid I need. But if this machine doesn't have any nitric acid to run, then it doesn't create any water. So I need some water to get this whole thing started. And that's where the buffer comes in. I'm going to be able to fill up the buffer ahead of time, and then that way it has a little bit of water. It can start running the nitric acid. And then once this kicks in, that amount that's in the buffer should basically stay the same. If I wanted to, I could then just delete the buffer and just connect the pipe straight across. But I also don't think it's going to hurt, so I'm probably just going to leave it there. Because the blenders are spun 180 from each other, the inputs will be on this side for the nitrogen gas and then the iron plates. These are raised up to the second and third level because this blender is going to get merged up with the one next to it. Those two combined will go into a particle accelerator. I need 6 sets of this blueprint, but only 3 particle accelerators. So that belt going from here to there will be on the ground level, and then those can be load balanced above it. And the inputs on this side for the blender look almost identical to the one below. I like the idea of having plenty of space. It's a pretty big factory, and well, let's be honest, space is not something I'm going to run out of. So even though there are definitely going to be parts that are a little bit cramped, like in the very middle of this blueprint, I want to give myself plenty of space along the edges. So I'm going to give myself 3 foundations on either side. These blueprints are exactly 5 foundations wide, so I am just going to slam these up right next to each other because I'm actually going to run out of space. 1, 2, 3, 4, 5. So this floor is just going to grow a little bit. I do love my blueprints. So I'll probably need to add on another 2, I guess. So once I add the walkway, I want to have the same amount of space. Yeah, it looks about right. Alright, so I'll clean that up. Next step is the particle accelerator. So actually, let's go ahead and find the center. Alright, so right here is my very center. Works out, it's right on the center of those, so that's where I'll make sure I put these. So we'll just center the particle accelerator on the middle of the 2 blueprints. Like I said, I'm just going to grab a merger, probably place it right about there. Each one of these is going to output 100. So we can grab a Mark II out of each of these blenders, and then Mark III into here. And then go ahead and set our plutonium pellet recipe. These are also overclocked to 200%. There's the 200 non-fissile uranium, and then this ends up being 1/4 of the waste. And so for those, they'll get load balance just right above that, but hey, 3 machines. I like that kind of load balancing. The next step is the assemblers. Normally I would need 18, but we'll just go ahead and overclock them to 200%, so I need exactly 9. Which means for each particle accelerator, I need one of my blueprints of 3 assemblers. So we can just get these placed right in front of these. These are making the encased plutonium cells, overclocked to 200%. Each machine needs 20, so for the set of 3 that needs 60, which is what each one of these particle accelerators is outputting. So I just need 1 belt into there, and then I just need 1 more splitter for the concrete, and I can load balance it across the 3 blueprints. And for the last step, I just need manufacturers. So normally I would need 12, but we're just going to do the same thing. Overclock it to 200%, and I only need 6. So I'm just going to center each of these blueprints on, well, I guess the water buffer, because that should be the middle of that blueprint. And these will make my plutonium fuel rods. Each one will make a whopping 0.5 per minute. I just need to bring in the steel beams, electromagnetic control rods, and the heat sinks. When I bring in those 3 parts, that will use these 3 lifts. But for this step, we're going to merge up all of the assemblers. Each one of these are going to output 10 encased plutonium cells. So out of here, I'll have 30. It's going to go a real short distance and then go into a splitter. And that's because each one of these needs 15. So it's just easiest to do 3 to 2. I've got all the machines in place, and like we just kind of covered, the bell work is all fairly straightforward. So I'm going to go ahead and skip ahead, and I'll show you what that looks like, and then we can move on to the final floor. Still a little bit more belt work to do here in the front, but there's 6 sets of machines, so it'll be pretty straightforward. In total, I need 720 nitrogen gas, so I figured 2 pipes of the 360 is probably going to be easiest to deal with. So I can just balance those across the 3 machines each. And the rest of the just real basic belt work is done. And now we are on to the final floor. And because this floor really doesn't need to be that big, honestly, I don't even think it needs to be the size that it is now. I did bring it just back in line with the very first floor. As we can see here on the spreadsheet, I actually need very few machines. Instead of 3 particle accelerators, I'm just going to place 2. With the quantum encoders, I'm going to go ahead and place 4 because I actually think that is going to be easier to deal with. I could place 3, but if I have 2 particle accelerators, I think it'd just be easier to have those just feed into 2 quantum encoders each. And then for the excited photonic matter, I only need 1 converter. We start with the particle accelerator, and I'm going to go ahead and give myself plenty of space, so 3 foundations on each side. And then this one will go probably right around here. I'm probably going to have to move it, but let's go ahead and just set the recipe real quick. These are doing fixonium, overclocked to 150%. In total, I'll be generating 30 plutonium waste, so each one takes in half of it, half of the singularity cells. And here's the other reason I wanted to do 2 particle accelerators. Each one requires 300 dark matter residue. In total, they need 600. The quantum encoder, let me just place one down and set the recipe. Doing the fixonium fuel rod, these are also overclocked to 150%, and so each one is going to output 75. So when there's 4 of them, that'll output 300. And if we come right over here and zoom in a little bit, that chrome pipe right there, which I'm pretty sure is actually full. Let's get a little bit closer. Okay, good. Made me a little bit nervous there. This pipe right here is getting 300 dark matter residue per minute from that factory. So I could combine it and then resplit it up, but why? Instead, I'm going to have that pipe feed 1 machine, and then all of the quantum encoders will get grouped together and they'll feed the other machine. So that's actually pretty much where I wanted to put it. And then I think I'm just going to space these out just a little bit. We'll just give them 1 foundation each. I thought I was going to have to move them. Go ahead and center it on the 2. Alright, so this will obviously get split into those 2. Same thing with that one. That takes care of the fixonium. The electromagnetic control rods and the trigons are on the belt right down there. So the last part is the excited photonic matter. And for that, what I'm going to do is something a little bit different. I'm going to put it up here, and I'm actually going to raise it up just a little bit. I'm going to make this look a little bit prettier, but I think I'm going to go up probably 6 foundations. And the single converter can just sit right up top here. And this is also going to be overclocked to 150%. That'll create the 300 I need. And I think this should be at the right height to be basically just on top of everything. So the way I can do this is, let's see, the first 3 things are all going to be solid. And then if I switch to my pipes, I line this up, hit H, and then I'm just going to nudge it up and then over. Now it's in the right spot. And then what we can do is just grab the stackable pipeline support, go up 3, and then in good old horizontal to vertical, plug that into there, and then switch it to straight mode, and then into there. And in the very center, I can just skip the very bottom one. I just need the 2 splitters, and then I do the same thing with the pipeline junction. And so that's how we'll feed in that. I'm going to move the machine over so that the pipe is centered on this foundation. And that way I can just have one straight pipe that leads into here. And that'll feed the excited photonic matter into all of these. And then I'll be able to do a kind of similar thing to group up the dark matter residue. And I think I'll just give everything a nice long runway for all of the parts. So I'll probably just have the mergers way out here. That way I can see my finished product rolling across the floor. So this will pick up all of the fixonium fuel rods and then send them down to the power plants. And then for the dark matter residue, I'm pretty much going to do a mirrored setup just on this side and not quite as high. Thankfully, the plasma gas thing that the dark matter residue is doesn't require any head lift, so I don't really have to worry about moving this up over the pipes. But I'll group up those two, and then I'll have one in the center, and that'll group everything up, and then those will come around here. And that's going to feed into this one. And that would work fine once the system is completely up and running. The only problem is I need the dark matter residue for this one to start, and then you just end up waiting a while because this one would be able to run right away. It'll have a constant 300 per minute of the dark matter residue being fed to it. And it wouldn't be the end of the world because the plutonium waste can stack up really high. So if it just took a while for this one to finally get up to 100%, I think it would all work out fine in the end. Or I can just use a temporary buffer. So there's a couple ways I could do this. I don't really know if I want to keep the buffer because like I said, once the system is up and running, it should just work fine. So I could have all of those pipes plug straight into here. And then from here, I go into here. And then I could just fill up this ahead of time. I could even add a valve right here to make sure that the rest of the pipe doesn't fill up so that when these things do turn on, they can immediately exit and that pipe will never be filled up with the excess that I have. Or if I'm not sure I want to keep it, I can put a junction right here and then I could do that same thing. I could add a pipe here and instead of this pipe plugging into the back, I can have it plug into here. And then from here to here. And then I can do the same thing with the valve. And then that way, when I do fill up this ahead of time, it won't backflow through this pipe and fill it up too much to where these can't empty. And then once this whole thing is up and running, I could easily just delete this. Delete these right here, just reconnect it. And it would just continue to run. I may just leave it there because it's probably not going to hurt anything. And hopefully this doesn't happen, but you know, if my world does somehow crash completely and I have to restart things, it'd be nice if it was already full, I guess. Let me throw together the basic belt and pipework here. I'll show you what it looks like, and then we can move on to building some power plants. Now I've got a few more belts and pipes. So normally I have the colors completely switched, and I would put the excited photonic matter in the chrome pipe and the dark matter residue in like a copper pipe. But I actually really like the contrast in the colors doing it this way. So the copper pipe is now the excited photonic matter. These will glow that like bluish white. And then these chrome pipes are going to be doing all the dark matter residue. So as of right now, they just get grouped up together right here. And then like I said, I'll bring that over to here, probably figure out a buffer situation, and those will go into that particle accelerator. The ones coming from the other factory will go to the far one. But everything ended up fitting, no clipping or anything. We've got the excited photonic matter on its little stand here. So I gave it some supports with some big concrete pillars and just some frame pillars. First off, I just thought it would be cool to raise up the machine instead of just putting it at the ground level and then making the pipe go up and over everything else. And I had so much room, I wasn't really worried about this taking up too much space or anything. And it gave me a fun little challenge to try to make it look good. I did end up shrinking the floor since I figured that corner is going to be the one where everything comes up or down. As you can see, I've also built a few foundations, but we'll get to that in a second. This corner is lined up for all three sides. The rest of them are, well, just not. And yeah, it really didn't need to be that much bigger. So because I'm still going to enclose this part, I'm probably still going to extend the yellow foundations out. That's for future me to work out. Let's get to building some more machines. One of the biggest challenges when you want to scale up nuclear is the amount of water you need. I'm sure some of you enjoy seeing just a gigantic field of the water extractors and just miles and miles or kilometers and kilometers of pipes. And especially with curve mode, you can make it look really good now. But as you've probably guessed, I am not going to do that. I'm still going to have to deal with just as many water extractors as I would doing any other setup. But the way I'm about to do it will avoid all pumps, and I can keep all of these pipes so much shorter. Line these up with basically the half foundation in the back. And then I'm going to center it on the third foundation, basically the middle one out of each 5 that it's going to take up. So let's go ahead and place the first one here, and then I'll also place the second one. Let's just go ahead and place this whole first row. So the way I've designed this is 6 of them will fit in a row. And this is just enough space, so I am going to have to add on a little bit more. And I'm sure you can probably guess what that red line of foundations is. So, thankfully, this has plenty of space before I start dying. And this first row is going to be doing uranium. For the solids, it's going to be pretty easy. I'm just going to do just my normal load balancing. I'm not sure which one will do which. Let's just say the splitter will go on the bottom, and then we'll do the merger facing the opposite direction on top. For the bottom, we'll split up the actual fuel rods. The top one will merge together the waste. Be those two, and these two. And then in the very center, I can just place one more. And then both sets of belts will be able to input and output right down here. So we'll have plenty of space for all of that. There you go. So it'll look something like that. And then we just do the typical load balancing for a set of 6. Now, as far as the pipes go, because each one of these power plants are going to be overclocked to 250%, that means I need the full 600 meters cubed out of each of these pipes. I'm going to go ahead and use my handy lookout trick. So I know a water extractor is exactly 2.5 foundations wide. That means if I go to the 1 1/4 mark, be right here, that would be the dead center of a water extractor. So I'm just going to nudge this out 2 meters and go ahead and place this here. Switch to my water extractor. Now I can lock it in place, and unfortunately you can't nudge it, but I can make sure that it's in the right spot so everything's lined up. Go ahead and place this. Before I place down a whole bunch, let's go ahead and color it and load it up with power shards. Let's go ahead and grab some more. I think I'm going to go through a few power shards doing all of this. $12 water extractors for the 6 power plants. So the first thing I'm going to do is bring this to the foundation. And I like Auto 2D because it just makes it as straight as a pipe as possible. Since it does have to go up just a tiny bit, I think that's the easiest way to deal with it. Now I'm going to take a pipeline junction, place it 2 meters in from the edge. And that will be lined up perfectly with the input over here. But instead of leaving that at the ground level, let's go ahead and page up 1, 2, 3, 4 meters. So there's kind of 2 options you have here. Either I could leave all of this Mark 1, and then from here, I could make it a Mark 2 pipe. And that should work fine. The person who wrote the Pioneer's pipe manual that is so helpful for all of us, I'm pretty sure they recommend doing it this way. For me personally, if I need a Mark II pipe, I just make the entire system Mark II. It's worked out well for me, and so I'm just going to keep doing it. And now we can use my favorite measuring stick. And if we go from the bottom here and we go up 10 meters, that's how much head lift I get out of each water extractor. And yeah, it looks like even the bottom part of the pipe is about level with the foundation. So this should have no problem getting it into this pipe and into the reactor. And I should be able to do this entire thing without any pumps. Sure, I'm not really saving a ton of power, especially when you're comparing it to how much I'm making. It is not a big deal if you need to use some pumps. I just think that if I can keep systems as simple as possible, and there's fewer junctions, valves, pumps, or anything else that are attached to the pipe, I think it just gives it the best chance of succeeding. Fluids are special. I like to keep it simple. Instead of having miles and miles of pipes, I'm going to keep them really, really short. Alright, well, as you can see, I've got a few rows here. So these first couple, actually, this one is going to be spun 180. This one is also going to be uranium. And then this one and the next one are both uranium. So that'll be 6, 12, 18. Here are my 24 nuclear power plants just for the uranium fuel rods. So now I have 4 rows of 6, so load balancing across the 4 different rows will be easy. I just pair up these 2 rows. So I'll have a splitter and a merger right here. And then I'll do the same thing for those 2. Right here in the middle, I'll have a splitter and a merger. And then one last splitter and merger in the very center to split the rods and then combine all of the waste and then send it back into the factory. And so now we're on to the plutonium ones, which we're going to set up pretty much the exact same way. We're going to do the same thing, completely overclock it. But now these ones get turned to blue and yellow because they're plutonium. So I'm going to do the same thing. It's going to be a row of 6 and then mirrored right behind it. 2 rows of 6 will give me the 12 power plants I need for the plutonium fuel rods. And then we have one last row out here, and that is going to be the last 6 I need for the fixonium. The spacing the same as all the others. Make those 2 different shades of yellow for the fixonium. There we go. Perfect. The great thing about these is even though they are fairly expensive, I don't really need all that many. And out of all of the things to run out, it's actually cable that runs out the fastest. But for each row, it doesn't really take that long, and then I can add the water extractors, and by then everything in the dimensional depot is refilled, then I can just work on the next row. I just need a few more reactors, and then twice as many water extractors, and then some really easy belt work. But this is all pretty easy. It's just rinse and repeat over and over again. So let me show you what it looks like. Isn't it beautiful? I love it. It's still missing a few pipes. It was easiest to get all of the belt work done without the pipes in there. But now I can just go back and quickly add them. I ended up spacing out the water extractors 4 meters because it had the space. It made the gap back here a little bit smaller. And then the angle wasn't as sharp to get the pipe up that like 1 meter. So I think overall it just looks a little bit better this way. So for the fixonium, obviously it only has the input. And I finally don't have to deal with waste once I get to this step. The rest of these have the 2 belts. I went ahead and switched it so the incoming rods are on top, because that belt will be less full. And then the bottom belt will be the waste, and that will head out this way. And here is where I finally make a big change as opposed to every other factory that I built. I am finally going to just use the fastest belts just so I can get products from point A to point B faster. Because let's be honest, going from here to there with all Mark 1 belts, granted, it would look cool. With all Mark 1 belts going from here to there with the fuel rods, it would be like 1 every 20 meters, I think is the way the spacing would end up working out. So I think it would look really cool. It would also take the startup for this factory probably close to 2 hours. With smaller factories, I really don't care if the startup time is a little bit longer because I use the slower belts. Once the factories get up to a certain size, I've always been a little bit curious just how much faster I could get it to all start up if I used more of the faster belts. So that's what we're gonna do. I may upgrade these to like Mark II or something like that just so they move through here a little bit faster. But I'm not going to do Mark VI all the way up to the machines because I do still want to see the fuel rods. They look cool and it's all my hard work. I don't want to see it just zip by at 1,000,000 miles an hour. So this will be my compromise. There will be a little bit of section of the slower belts, but a whole bunch of this, I'm going to use Mark 6 just to speed this thing up. So the Fixonium fuel rods will travel along this set of foundations. The plutonium will travel along this one. And then I needed 2 sets of foundations for the uranium because I needed to do that little bit of load balancing out here. Get split in half, and then split in half, and then we go into their respective rows. This is definitely not going to be the fanciest or best looking power plant you've ever seen, but I am going to try to make it look at least a little bit better than the bare bones it is right now. But there is plenty of work to get to before I start messing around with the decorations. So the next 2 things I'm going to do is rearrange this a little bit. I actually think it's going to be, yeah, like that. So we'll have the uranium go up that side, and then we'll have the plutonium, and then we'll have the fixonium. Just build this right off the side of the cliff. And, well, actually, maybe I'll bring this over one more. Alright, so I'm probably going to set everything over 1. So this one will be the fixonium. And that way I can miss this coal node. It is only an impure, but still, I don't want to just cover it up and not be able to use it in the future. I can easily avoid it. So then this one will be the plutonium. It'll be the center one. And this is how all of the rods will get out to the power plants, and all the waste will get fed back into the factory. So just a little bit more belt work to get it from here to there. And then it's basically all of the in-factory logistics. Normally the way my factories would go is things made on the first floor would then flow up to either the second or the third floor. And, you know, most of the things would just kind of keep flowing up the factory. But this factory is very different. Each one, its final product is just going to leave. When its byproduct comes back, it goes to the next floor. It's just different enough to feel really different. So most of my in-factory logistics are going to be figuring out how to deal with the sushi belt. This sushi belt has pretty much all of the missing parts. It's a little bit hard to see because they just shoot by so fast, but it has all the different electromagnetic control rods, which I need to go to all 3 floors. It has my heat sinks, my trigons, the encased industrial beams, and the iron plates that I need for the nitric acid. So once those come into the factory here, I've got some space to work with, and I'm probably going to add a little bit more just so I have some more space. But I'll just do a little bit of load balancing, splitting things off, and then figuring out where they need to go. So I'll be able to use that space under there, and because this middle floor is so huge, I'll probably use this space out here to get things out and up instead of running them just straight through the middle of the floor. It'll just help switch it up and make things look a little bit different. And that way I can use up this space right here to feed everything in. Now I've got my beautiful bright and shiny Mark 6 lifts in. They come up to right here and then head over to the factory. So as we can see, the uranium fuel rods come from the first row, but then the waste then go to the second row. And then the plutonium fuel rods go down. Plutonium waste goes up to the top one. And then the fixonium fuel rods go down. Which meant, by the way I laid things out, and they need to do a little bit of crisscrossing on these floors, but that's alright. You only have to do it with 2 belts, it's pretty easy. And then the rest of the in-factory logistics, so getting everything from the basement up to this top floor. So I needed the dark matter residue, the trigons, we've got singularity cells, and I think the electromagnetic control rods. And once I got that pipe up here, I went ahead and just plugged it up and filled up the industrial fluid buffer. So now this is nice and topped off. So this will be able to run for plenty long enough for these ones to get started, and then they'll be able to start feeding it. And then whatever that's at will probably just stay the same, or I could delete it. I decided to make the belt for the silica like my pure bright white, and I think it might be just a little too bright, so I may tone that color down just a little bit in the future. So I'm sorry if it's a little too blinding right now. All of these products are coming up from right here, like I said. I just created this thing to be both kind of a support and a way to feed all of the products from the basement all the way up there. So we'll take a look at the basement in a second, but this is basically the products that go to the front half. These ones go to the back half, and then I'm still gonna have to figure out how to get the nitrogen up here because I haven't quite done that, but that's coming from way over there. I'll figure that out later. I've still got plenty to do. When we come down to the first floor, everything is just coming up from a similar spot, just straight up through the floor. We've got all of our nice color-coded Mark 6 belts. So I'm really going to lean into, let's just see how fast we can get this factory to start up. I also think the other advantage of everything just kind of starting up as quickly as possible, I will end up with less radioactive materials in the factory and make this less of just a giant radioactive hotspot on my map. It's still probably going to be one, but I'm hoping I can at least walk around the factory a little bit. No matter what, you're going to need a hazmat suit and the iodine filters, but I'm hoping that you won't just burn through them as fast as possible. The other thing I went ahead and did is built all the singularity cells over, because that pretty much just got to be a straight shot, and since it's just the one belt, although I am now realizing that this is too many singularity cells. I think I just belted over the entire thing, but I really only need 3/5. I'll fix that and I'll show it off later. Just one simple ratio split, and then about 10 minutes for the line to clear out. Let's go ahead and venture into this basement. Alright, so this is pretty much what I had before. I just sent the dark matter residue pipe over there. And then I had the sulfuric acid, and then everything else kind of got added. So I did need to do a little bit of load balancing, but as you can see, they're pretty small. So let's run through them real quick. Alright, so the way this works is those two belts are going to deal with the sulfuric acid. This belt is just concrete. And then this is my sushi belt. So this belt comes over to here to a smart splitter. All of the trigons go to the left. They're only used in one recipe. The electromagnetic control rods, however, those go straight ahead. Everything else goes to the right. We've got the electromagnetic control rods coming out of here, and these go into a splitter. In total, I have 108. I need to split these up 60, 30, and 18. I can actually divide all of those numbers by 6. So that 108 actually becomes 18, and I need to split it up between 10, 5, and 3, which is just a little bit easier for me to work with. So if we just say this is 18, we split it in half. There's 9 and there's 9. Use all 3 outputs. We've got 3, which is one of the numbers I needed. 3 and then 3. This 3 gets split into thirds. So we've got 1 plus this 9. Here's my 10. And then 1 and 1 meet up with these 3. Here's my 5. So even though the electromagnetic control rods needed to go to 3 different places, it was about as easy as I could ask for having 3 different amounts. And then they just head off to their appropriate floors. So this one ends up going off to the top floor. This one right here is the first floor, and then this one goes all the way around, plugs into the part that goes out and up to the second floor. Alright, so if we go back to this smart splitter, trigons went that way, electromagnetic control rods that way, everything else went that way. Which brings us to another smart splitter. This will branch off the encased industrial beams and then send everything else forward, which goes into another smart splitter. Iron plates get peeled off here. And then last but not least, we'll have steel beams and heat sinks, and then those get split off. Everything just needed to pretty much get plugged into the appropriate spot, go up to the right floor, and then get routed to the right splitters. The only other load balancing I had was for the sulfuric acid. I'm dealing with 900 per minute, and so that is coming out of there. And then we're going right into a merger, which is probably pretty telling. And so is this layout. Just doing a simple 5-way split. This would be 3/5. Here is 1/5. So we're doing 4/5 here, and then 1/5 that goes on that way. And this is the part that loops back. The second floor only needs 180, which is 1/5. So this ended up being pretty easy to deal with. Oh, and there's one last piece, so you'll see just a floating merger here. This lift right here has half of the canisters from this first floor. Should be 360? Yeah. So that's 360. And then this lift right here has the other half. And then this last belt is coming from the second floor, which will have 180. Which makes sense because I'm sending up the 180 sulfuric acid to the second floor. All of the empty canisters get grouped together. Come along here and plug into the industrial storage container. And that completes the loop for the sulfuric acid into the empty canisters. Don't worry, this isn't going to be here forever. This just has the extra empty canisters, and what I'm going to do when I start this up is I just need to plug this belt in, and that will send all of this sulfuric acid into the factory. And at the same time, what I'm going to do is just delete this container and put all of them in here. This will do its real basic load balancing, and then start sending 900 empty canisters to the other factory so that those can start being turned into the packaged sulfuric acid. And then that way I just have probably a few thousand extra canisters in the loop. There is definitely a sweet spot with a setup like this. You can have too many and you can also have too few. Thankfully, with having 2 industrial storage containers, I have quite a bit of wiggle room. And I think this will be just the right amount where I'll end up with a nice little buffer, but not close to having too many. Next up on the agenda, another belt highway. There are 2 things that I need from the train station, and that is how those are going to get all the way out here. It is a pretty good distance, and I thought about using a train, but I also felt like that was just going to be more of a pain than it was worth, to be completely honest. I need 2 belts. One is going to have 300 silica on it. The other one is going to be a completely full Mark 6 belt of 1200 uranium. The uranium is already going to be coming from 3 different places, and I'm going to have to figure that out already at that train station. Transferring them to just other trains to bring over to here just seems like more of a headache. I'll get the different amounts merged up, we'll get a completely full 1200 belt, and then we'll send the 2 of them all the way over to here. And then in the future, this will also give me a little bit of infrastructure to work with for when I bring the nitrogen pipes, which are going to be coming from, we zoom in, all the way over there. But hey, nitrogen doesn't need head lift. It ended up being pretty standard belt highway for me. I just reused one of my double belt blueprints. The only part that got tricky was when I ran into this thing. I really wanted that to be centered on the factory just because I could, and I like the way that that looks. But that meant it was going to run right into here. And I probably could have tried to curve it on the inside of this. I would have just had to move this probably over to more of like the corner. And I just didn't feel like having to plug into the corner. So I just built its own little platform using some beams and just bolted it into the rock. And so now it just kind of curves around it and then goes into the train station. Or I guess those are coming from the train station around it out over the factory. Normally, I would leave the uranium to the very last step because why burn through more of your filters before you need to? But because I think all of it is going to be coming by train, I really want to make sure that that is all sorted out ahead of time. So that is what I'm going to work on next. We take a look at the map with the resources on. Ooh boy, is it busy. But if we look at the uranium, let me point out the ones I'm going to be using. I've got an impure node right here. That will give me 300 per minute. And I'm sure I can figure out a way to squeeze it in somewhere into that train station. There's a normal node right here, so that can give me 600. Now this is very deceiving because it looks like it would just be right at the edge of this lake, and I should be able to easily put it on this train station. Well, that's sort of true, but we'll get to that. And then the very last one, I don't actually have a radar tower that covers the area, but there is some uranium up here somewhere. I think it's on this middle part. Maybe it's over here. I don't know. It is up there. But that'll be the last one I build. I'm going to hop in my train and head out to the swamp, and that's going to be the first uranium node that we grab. Back to the swamp. Thankfully, I've put so many factories out here that not too many spiders spawn anymore, and that makes me happy. Out of my 3 usable train stations, the middle one is the one that doesn't get used nearly as much as the other ones. This train actually waits here for, I think, 5 minutes. It's actually waiting here for 10 minutes. So instead, we're going to create a little bit more traffic on the tracks, but I think it'll be okay. And this is going to get switched to 0. Because now I'm going to have 2 trains going to this. Once I grab this uranium node, that's going to be my next stop. And then I can take a look at this train station. And if there's no other trains going to this one, I'll just switch the 10 minutes from this current one in the swamp to the one in the eastern dune forest. But if 2 trains are stopping here, then it'll just continuously run. It's really not the end of the world. So what I can do is just cancel the docking, because it had already done the docking. It was just in the 10-minute wait period. Now I can have a second train come here, and it's only going to be picking up from this freight platform. That's plugged into the wrong one. Let's plug it into the correct side. There we go. And then I just need to add my small storage buffer down here. And now I'm just going to come out through here. What I'm probably going to do is have it just run right along this series of belts. So if we come to the waterfall and you come right through it, of course that's where the hidden treasures are. And then right on the other side, there is my uranium. Let me throw together something to get this belted over that train station. To get it to where it needed to go, we had to just kind of wind through a little bit of the swamp here. But that way I didn't have to change elevation a whole bunch of times. And it could just fit right through here. The big frame pillars are really handy for being able to give your lift a little bit of support. And then that comes in here. I got a lot of use out of the curve mode doing this. And then it just drops down to the floor here. And we've got our little uranium housing. Completely overclocked. I can get 300 uranium out of here. So let's go ahead and just turn it on. Especially for things that are radioactive, I am just going to use Mark 6 belts, because the quicker I can move them on there, that means that there's less actual pieces of uranium on like each section of belt. And so you can actually get fairly close to the belt before I start using any of my filters. I can still be this far away and I'm not using any. Whereas if this was the Mark 4 belt, since there's 300 on here, it would probably make a bit of a difference. Now that it's turned on, I should probably figure out where it's going to go. So I'm going to go back to the Dune Desert and set up my unload balancers, and that way this has somewhere to go. I can start sinking it and I don't have to worry about it piling up and creating a huge hot spot of radiation. I've done this setup for 300 parts per minute a few times, so it's pretty easy. I just need the Mark 4 belt going into a splitter, using a Mark 1 and a Mark 2 belt that equals 180. So that gets looped back into the container, leaving me with 300 to go into the sink. It's never really a bad idea just to throw the throughput monitor on there and just double check. And here's the one train picking up the uranium from the swamp. But I am going to use this train station for all of this uranium. The next 3 are all going to do 200. I've grabbed this uranium. The next one that I'm going to use is this one, which is a normal node. So I'm going to be able to get 600 out of there. And going from here to here, I could probably split that among 2 freight cars. The freight cars have 32 slots. 300 a minute would basically be 3 slots. It would need to complete its round trip in about 10 minutes. And I'm pretty sure it would be fine with doing that. But if I split it across 3 freight platforms instead of the 2, then it has even longer. Which also means that if it's running all the time, the freight cars will just be less full and less radioactive. So if I need 3 of these unload balancers, I might as well make it a blueprint. So I just made my diagram and followed it. We've got the industrial storage container, and then this is going to be a Mark 3 belt. So we've got 270 into a splitter. That puts 90, 90, and 90 on each of these belts. Group up 2 of them, there's 180. With this 90, we're then going to split it into thirds again. So 30, 30, and 30. And then with this 30, we do it all over again. So now we've got 10 and 10 plus the 180. There is my 200. And here is my 70 that gets looped back into the storage container. Because I've already got a bit of load balancing going on up here, I just had to get a little bit creative with some of these and drop them down where it was convenient. So this one had to just drop down like right through here, but hey, there's no clipping. And now I've got my 3 floor holes to work with right underneath these glass foundations. And now I've got my blueprint here, and because they're probably not all gonna line up super straight, what I'm probably gonna do is just fit this one kind of over here. And let's see where we can fit this one. The beauty of these being blueprints is it's so much easier to be able to kind of fit them into spaces like this. Now I can just nudge the whole thing all at once instead of having to rebuild it when I'm off by 1 meter. And then the last one is right there, so that one can just be even with this one. Perfect, and now I'm gonna have a separate sink for these, just so I can have a different throughput monitor and make sure each of the different trains is running the way it's supposed to. I'm gonna go ahead and skip ahead and show you what the Eastern Dune Forest loading part looks like. My busiest train station keeps getting busier. Thankfully, this train station only needs the first 3 freight platforms, and it's gonna have a different train than the one that goes to the swamp. I am pretty sure I could just use 1 train and have it go to both stops, but I also know that having the 2 trains will just make sure that they have more time for their throughput. I'll show you what the new chaos of inside looks like, but for now, let's head back. We've got our 1 line. This is gonna have 600 uranium on it. This comes right across the lake. Just gives these water extractors a slight dose of radiation. And this is where I got it from. Using the exact same trick I used in the Dune Desert to get the SAM out of that cave, I did to get the uranium out of this one. This one is a little bit different because, let me delete this and show you. I needed to use a foundation with a floor hole, because if I highlight this, you can see that is way longer than what a normal lift will go. The only way I can think to show as an example is I'm going to place one here, and I'm going to drag it all the way down. I'm just going to lock the hologram in place, and then let's go down to where this is actually coming from. There is 2 entrances to this cave, so if we head past my copper setup right here, and right around the corner, through here, there's a cave right underneath the red jungle. Let's head down through here. And it's quite the journey. And here we are. So there is a pretty big cave down here. It is just way down here. But as you can see, we've got our uranium node. And this is the way it's getting out of here. So it just goes up, and then I just placed a whole bunch of concrete. And then it goes through here, and then into a floor hole. That right there is the foundation. And as you can see, there is my lift. I can rotate it. That is as far as a normal lift will go. So this is a huge gap going from there to there. And so the only way to really do it is to use the infinite lift trick. And so that's why it looks the way that it does. But as long as you use the global grid by holding control when you place the foundation, I can make sure that when I place a foundation here, and then I go up to the top of that lake, as long as I get it in the right spot, I know that if I place a floor hole in the middle of this one, and then in the exact middle of the one up there, they will be completely aligned because of the global grid. Because if you're off by just a half a meter, the lift just won't give you the option to do the infinite lift trick. They have to be perfectly aligned. Now we can double check. Perfect. I've got all 600 out of here. And let's go ahead and turn this one on too. The other entrance is if we head out through this way. Not nearly as much cave to go through. It just puts me out way farther away. You follow this little stream. It ends off at the void. My immerser sphere that I probably really don't need anymore. So this is the smaller of the two voids over here. So if you follow that little creek, that is how you can get to the uranium a lot easier. And as you can see, I just used a marker, which if you've never used them before, they're pretty cool. This is how I found out, where exactly to place the foundations. If I hold Alt and then left click, it does the ping. And it's kind of nice to be able to measure. It's 111 meters to there, or 252 to there. But if I Alt and right click, it will give me the option to place a marker. So I can place a marker there. And now when I go to my map, if I move away from it, now we can see it's right there on the map. And so that's what I use to be able to line up the two foundations. I placed the one kind of as far over as I could in the cave. And then I went to the very middle of it, placed the marker, and then went to the top of the lake, which if we just head up through this way, we can get to. Oh, yep, it's on this side. And then when we come up here, then I just look at the map and I zoom in and, you just kind of get yourself just like right on the exact same spot. And that's where I needed to place the foundation. But out of all the different ways to get the uranium out of that cave, I like this one the best. It takes a little bit of work to find the exact spots where everything lines up and it doesn't look too horrible and whatnot. But I still much rather do that than have that just ridiculously long belt trying to get out of the cave. Now this heads right along here, and let's take a look at the insides. Enters the train station here, and then we head right over here. We've got our buffer, and then that goes into a splitter, and then splits between the 3 different freight cars. Definitely should have given this train station a little bit more space down here. Well, I learned something every playthrough. The Dune Desert 3 train station now has 2 trains, and it has almost all of the uranium I need. This is receiving 900 out of the 1200. And the last 300, it's actually fairly close. Up here on top of the cliff, I've got a nice view of the desert. We've got this fun thing that's got some water spouting out of it. If you've never been up here, there is a fun little hidden treasure found on this thing, along with just a million hatchers, so just be wary of that. But if I turn right over here, the last 300 I need. I mentioned before I could use a belt because it's not too far. I mean, I probably have longer belts in this world, but I am going to build a train. And that's because in the future, I have a feeling I may want to use both of those nodes. And I think it would just be easier if I could belt those over to here, put them on the train and get them down there, instead of having to either add another train or add more belts, or I just don't want to have to figure those out now. And trains give me the easiest way to just adapt later. So I'm thinking somewhat kind of in the middle, because I don't mind having a belt go from here to probably right around here, I think. And then I can use this area right here to be able to get down. I'm going to try to keep this train station fairly compact. Since it only needs to do the loading, I don't have to do any crazy load balancing up here or anything like that. We'll just need one small storage container for each of the different buffers. With it being such a short trip, this is going to have no problem doing the 300 on one freight car. Sulfur could probably deal with just one, but it would be much easier if I split it into 2, because that sulfur node is pure. And then the SAM node definitely only needs one freight car. So at least those are there for the future, although I'm not going to plug any of that up now. What I really need to figure out is how in the world to go from here down to there. So if you're curious, this is the point where I started playing around with different ideas of how to make a steeper track, which led me to record a whole different video, which I haven't put out. Once I recorded and I was editing that video, I realized that I could use those tools to beat the top train speed record of the game. So I'm selfish and I wanted to do that. So then I recorded that video and put it out. even though I said this video was going to be way more on time. Well, I decided to have fun with trains first. Let me go through the basics. I am still going to put out a little bit more of an in-depth video on those and kind of their limitations. But the nice thing with this setup is the train is only ever going to be full on its way down. Coming back up, it should always be empty. And that makes a big difference because if you want a full train to go up a really steep track, you're going to need a lot more locomotives. But going downhill, it just gets to go real fast. So if I lay a beam down here at the bottom, it can go 32 meters in a Mark 1 blueprinter. A 4 meter ramp is for every 8 meters, it goes up 4. So that would be 16, which would be too tall. So if I did 16 here, and I put this in diagonal, and I grab my rail here, it won't actually let me place it. But if I make this just a tiny bit shorter, just even 1 meter, you may need to put it in free form instead. Now I can place it up here, and then I'm going to hold control to force the rail to be straight, because I definitely want it to be straight. And then I'm going to place it here. And now this is a really steep track that I can place that it'll have no problem going down. Going up, it's going to go fairly slow, I'll be honest, even with 4 completely empty freight cars with 1 locomotive. But this is a push-pull setup, so there's only ever 1 train on there. It really doesn't matter how slow it goes. Using that methodology, this is what I came up with. 16 meters doesn't work. The example I showed was 15 meters. But in my opinion, I think it would just be easiest if I kept it as kind of a round number. This right here is essentially a 3 meter ramp, which I think is a nice kind of happy medium. Yes, I can make it even steeper, but it has a little bit of an easier time going up this way. And so this right here is a smoother version of if you alternated the 2 and the 4 meter. In the past, this is basically what people would say is the steepest you could lay out a rail, is alternating the 2 and the 4 meter, which would give you the equivalent of a 3 meter. So that's what I did. It's just a lot smoother this way. And the beauty of the concrete pillars and the beams is if I attach it right here to the end, when I nudge it using the arrows, it'll just nudge it along the beam. So that's how I got all of these in the right spots. And then I could just page them down to the right place and get them exactly lined up how I wanted to. So for this section right here, I'm just going to deal with the 2 meter ramp. And then once we get here, my original thinking was I would just kind of bolt this to the side of the cliff. But I forgot that it's not really just a giant cliff face. There's quite a few places to build on that step all the way down. So what I can do is just have the support still not be that long, and then just kind of stick to this kind of area, and we'll go out this way. And then once we get to probably here, then I'll have it drop down the rest of the way until we're level with the train station. And then I'll just have this one be at the very end, and then that way I can still squeeze in 1 more train station here if I need something else from the main line to come to this train station. So this is how I like to do it. I'll take a foundation and I'll drop it down 1 meter and I'll place it here. And now I'm going to switch to my 1 meter, and when I hold control, now I can kind of spin it into the direction I want it to go. And then once I find the angle that I want to work with, maybe that's a little bit too far, so we'll go back 1. That looks good. And you can kind of zoom to see where it's going to go. Yeah, that looks like the angle I want to work with. Now I can grab my beam, and I want it to snap to this foundation. So I'll lock it in place, avoid the spitters, deal with you later. And now I just kind of nudge it into place and then page it down a whole bunch of times. And a section like this, I might have to play around with just a little bit to make sure that this part still ends up not looking too bad. But thankfully, now that we can rotate the train line, I can just make sure that it lines up. Yeah, that'll probably work. And then we can connect to the train station from here. But for this section, all I need to do is take the blueprint, put it in blueprint auto connect. And if I snap it to the end of it, for some reason, it just acts kind of weird where some of the beams aren't there. So even though you have to nudge it more, I usually snap it to the bottom. There's only a few spots where this will show up. So once it does, you want to click it once and then continue to nudge it. And then once you get to the end, you'll notice that it doesn't quite line up. And that's because I just need to nudge it up a half a meter. I need to hold control and then hit page up. And now it should auto connect and it looks real nice and straight. And place that one and then rinse and repeat. And now I've got plenty of options. But originally when I designed this, like I said, I thought I was going to end up kind of bolting these to the side of the cliff. So I left this underside open so that I could figure out an easier way to make it look good. But now that I'm probably not going to do that, I'm probably just going to use some sort of pillar, probably the concrete, but same idea. And you can kind of just nudge this into place. Yeah, I think the concrete ones will look a lot better since this kind of has to clip halfway through it, but still a good example. And once I have those there, then I can just come back through and I can delete all of my beams. So let me work on this train track and I'll show you what this thing looks like. Here comes the new uranium train. I got the new train station added. And there's still enough room for one more. Go ahead and hop in and we can see how fast this thing goes. Honestly, for as steep as it is, it actually kept its speed up pretty well. We'll see the buffer kick in. There we go. And this is why you really only need the small one. I only need these storage containers for 2 slots. That's all that ever gets used. But here is my little train station. As far as trains go, I feel like this is pretty small and compact. Nothing too crazy with the design or anything like that. Just using a lot of the foundations for walls and then just the reinforced windows I felt were fitting for having a bunch of uranium go into here. And having the foundations there give me an easy place to plug in the belts. I can just kind of fake the wall holes like I've been doing. That gives me multiple places I can plug in the sulfur and the SAM in the future. Alright, well, I probably fiddled this for way too long and I forgot one pillar. Now it's actually supported. There we go. But I'm happy with the way this turned out. Being able to build the steeper track just really kind of helped be able to get down to the right distance. Whereas if I was only using the 2 meter, it would have taken just way longer. Probably closer to out to there, it would still be dropping down. Which isn't a big deal, but it's nice to have options. We come down to all of my unload balancers. I now have another new one. So that 300 is then getting grouped up with that first 300 that I grabbed. The 3 200s are all getting grouped together to create a 600 belt. Because I think when you merge 2 600 belts together, that is the best way to make a full 1200 belt. That is all of the uranium taken care of. Now I want to grab the last part that I don't have. And for that, we head through this canyon to the very top of the map. I think it's time to grab the nitrogen node. When I slap down this resource well pressurizer and completely overclock it, this is going to give me 300, and that is going to give me 150. So if I pair up a pure and a normal, that pipe is going to have 450, but my factory is only going to use 360 of it. So even though it's, I guess, a slight waste of nitrogen gas because I'm just not going to be using a bunch of it, I don't think I've ever come close to using all the nitrogen gas in the world. So I don't really mind. I'm just going to have a little bit too much in each of the pipes, and I am just going to pipe it all the way over there. But because it's a gas, I don't need any pumps. It's not the fanciest setup, but I wanted to add a little bit something, so some floodlights help. And normally the floodlights just look like that, and I think that's fine and all, but I really like doing this with them, where I can take the buffer slot for the trains, Because this one's at a diagonal, I just have to hit Control to get it to snap to the side, H to lock it in place, and then you can kind of play around with how much you want it to nudge into it. So I think I went with 3 on these ones. Yeah, and they just barely kind of crisscross here, and I think it just gives it more of a sturdy base. I've paired up 1 pure with 1 node for each of these pipes, and so let's just follow them all the way back. Once I got to the edge here, then I decided to curve that in. And now it just meets up with the rest of the belts. Oh, that's not quite right. I envisioned that being a little bit straighter. I'm gonna have to fix that. Then the nitrogen plug into here, and then I just have them come up with the rest of the belts. Once they get up to here, then they come along. And I just thought it would be fun to have them go straight through the particle accelerator for no good reason. So they just go up and over. Once they get to this side, then they split to their 2 halves. And now I think I have all of the pieces. That factory from the last video made pretty much all of the parts. The only things I was missing was the actual uranium ore and nitrogen gas. Okay, and maybe a whole bunch of water, but that's a minor detail at this point. With all the parts here, all the machines in place, all of the basic belt work done, I think it's about that time I spend way too long doing some decorating that just kind of looks alright. The save is currently at 405 hours and 18 minutes. Let's see how long it takes me. Welcome back to my nuclear power plant. The save is now at 415 hours and 25 minutes. Like I do with all my factories, let's start at the farthest points and work our way in. Which brings me back to the Eastern Dune Forest. I thought that this was important to show off. So the way that I had the loading side set up originally ended up kind of weird. Originally, the splitter was right here. And then it split off to this one and this one. I'm not sure, but I think there was going to end up being a problem in the long run. Because what was happening is when the train would stop, the middle freight car would only have, a few uranium backed up. Whereas the 2 sides would end up having, probably more than 10 pieces more than the other one. Every time the belt stopped because the train visited, the 2 outside freight cars just ended up having more. And I was afraid that that meant kind of in the long run that they wouldn't be able to balance to the full 200 like they were each time. So this is the system I came up with instead. The initial 600 goes into a splitter. Each one has its own buffer now. So now it doesn't really even matter, especially with how long this belt is. Because the split is done before the buffers, these are just always going to get the same amount. Say the train stops here every 10 minutes or something like that. In that same 10-minute period, each 3 of these lines are going to get the same exact amount. And when the belts pause, it really doesn't matter. Now these belts just act as extra long buffers for the storage container. Now when that same train stops, all of the freight cars are exactly the same, or at most they're only off by 1, which is exactly what I want to see. The next big change I made is unfortunately in this factory. Because of course, I can't make it through this factory without screwing another thing up. This screw up was over a year in the making. Past me of over a year ago was just a little too sloppy. And that's with the spreadsheet. I'm honestly kind of surprised it didn't happen more. Because to create this spreadsheet, I basically just went through the wiki and then found the information I wanted for each of the recipes, and then I input it in a spreadsheet. I have made plenty of errors. There's probably still plenty of spelling errors because spelling is hard. Most of the time, I transcribed the numbers correctly. But as you can guess, this time, I didn't. For the plutonium fuel rod recipe, it is supposed to be 2.5 heat sinks and 1.5 electromagnetic control rods. for whatever reason, I input 1.5 for both of them. That meant I was missing about 40% of the heat sinks I needed. I was making 18, but I need 30. And if you're thinking, I thought you said you were going to double check the numbers, I honestly thought I did. I put everything into Satisfactory tools, and I swore I went through every category to double check and make sure that all my numbers were right. And somehow I still missed this. Why is reading so hard? On the bright side, heat sinks only take aluminum sheets and copper sheets to make. There are a whole bunch of other things that I could have gotten wrong, and it would have been a way worse mistake. And that is pretty much where the upside ends. This is where all of the copper ingots are coming from for those copper sheets. The aluminum sheets wouldn't be too bad. It would be increasing the production over in the Eastern Dune Forest, and then I would have to change the load balancer on the unload side. But that really wouldn't take too long. For this, I'm going to need to bring in more copper and iron. I'm going to have to change all of my load balancing. And even with overclocking, I need to squeeze in one more constructor. Or I could just use the most powerful band-aid Coffee Stain has given us. The summer sloops. This way I could leave the machine exactly the way it is. It has all of the same inputs. Instead of outputting 18 per minute, now it outputs 36. So I just need to do a little bit of load balancing. 18 and 18. Split it 3 ways, 6, 6, and 6. I sync 6 of it. I merge up the other 2 on this line, which then get merged up with everything else. That leaves me with the 30. And now I have 6 heat sinks per minute that I can use for a future project if I ever find a use for it. Or they will just continue to get sunk so that the factory just continues to run. And if that's the case, you know what? I'm okay with it. At this point, it may not be the most elegant or the correct solution, which would be just redoing it the correct way and bringing in the right amounts of everything. But because of overclocking, I only needed 1 assembler, which meant that I only needed 2 summer sloops to make this all work. And it's just so much of an easier solution. Like when I originally built this factory completely wrong over in the corner there, I did try to figure out how many summer sloops it would take to slap a band-aid on that, and it was going to be way too many. But this only cost me 2, so I'm okay with it. Maybe in the next playthrough, I'll actually plan for using all of the summer sloops, and then I'll have to be way more careful because I won't be able to make mistakes like this. But this time around, I'm just going to go ahead and give myself the easy way out. Moving on to the train station. Here is my little belt highway. And I decided I needed at least a somewhat quick way to get out there from the train station. This is what I came up with, which is mainly made out of beams and then the hypertube attachment at the top. But this is designed so that I could just nudge this into place, and those beam connectors are already part of this blueprint. So that's how these kind of just work together like that. So I was able to just kind of place that on top of all of those and just use the existing infrastructure and get all the way out there. Thought it would be smart to have extra hazmat suits and iodine filters right before you get to where there's a lot more radiation. Unfortunately, you can only handcraft them, so I just hit spacebar and grabbed a snack real quick. And then I've got a whole bunch of iodine filters in here, and well, they're easy enough to make. We can always make more if I run out somehow. But unless you're in the most intense amount of radiation, they last a pretty long time. Let's jump in. Here we are on the first floor. I added throughput monitors to all of the incoming belts, and as you can probably tell already, I decided to just make all of the belts Mark 6. Well, for the most part. I guess not all of them. The empty canisters really don't need to be an extra fast belt because they're just going just on the other side of these foundations are those containers. They're not going very far. I've done 2 power plants that are, I guess, somewhat similar. I think this is probably on the smaller side of nuclear power plants that I've built, but this is going to start up so much faster. They've always taken probably close to an hour and a half, even with all the load balancing. And a whole lot of that was just the travel time, which once it's all up and running, I love the way that it looked. But it took forever for those things to travel on Mark 1 builds, the just super long distances they had to go. For the very bottom floor, I decided to add some railings, and then I've got some glass walkways here, some stairs so you can at least get down to the miners if you needed to for some reason. And then once you get to this side, I have the roll-up gate, but because they are 2 foundations wide, half of it is essentially clipped into the foundations. But I don't mind the way that it looks. And out here we have the front, and I've got some stairs. But let's go through the rest of the inside, and then we'll go over the outside and where the power plants are. And for the plutonium one, since this one needed to be a little bit out in the way, this one, the elevator was just the one spot where it kind of came up at a weird spot. So, yep, that's where this one connects. And again, a lot more Mark 6 belts. The only difference really is I only need to use Mark 1, but I decided to use Mark 2 here so they travel at least a little bit faster than normal. With it being such a short distance, the faster belts will obviously save time, but not a whole lot. So I'd rather admire the bright blue radioactive glow. So for like this one, it only needs to be Mark 2, but I decided to upgrade it to Mark 3 so they just travel just a little bit faster, but they won't fly by quite as quick as the Mark 6 belts. And for all the actual fuel rods, I'm using Mark 3 because this long of a distance with the Mark 1 would really take forever. So the Mark 3 is my kind of happy compromise. That's still, 4.5 times faster than the Mark 1 belt, but they won't shoot by in a blink of an eye like the Mark 6s. The sulfuric acid needs to go to the 2 different floors. The bulk of it goes to the first floor, and it's going to get used pretty much right away. This amount, I need to wait for the uranium fuel rods to get manufactured and then burnt, and then once the waste gets up here, then this sulfuric acid will actually get used. So if I had this go just straight into the packagers, it would unfortunately back up before they actually start getting used, and then it may throw off all the rest of my balancing, and plus, then the belt just wouldn't flow like it's supposed to. So that's where this comes in. Even though this is a Mark 6, it's only going to have 180 sulfuric acid on there. And I have that going into a priority merger. And then on the other side, the belt is missing. For the first few minutes of this factory startup, I'm just going to have them build up. Once I create the uranium waste and it shows up here, then I'm going to go ahead and connect this belt. And then I've just got my real simple balancer to get me to 180 again. That'll be a Mark 3 belt, so I'll have 270. We've got 90, 90, and 90. If I send back 90, that leaves me 180, and then I'm good to go. I thought about doing this different, where I just had a smart splitter and just basically sent everything to a storage container. And then once everything showed up, I would just delete these, and then I would take that excess packaged sulfuric acid back down to the basement, back into its normal buffer. But this is another case where, I guess, if things went wrong and I had to restart stuff, it would be nice to already have a buffer built into the system up here instead of it only be down at the bottom. Like I said, I don't think that's going to matter at all. But the other fun thing to think about is this small storage container is going to be able to hold the exact same amount as the industrial fluid buffer, just in package form. And so that's basically what I've done, is I've introduced a buffer up here, but I don't have to worry about sloshing. Hooray! The final floor, Exonium fuel rods. So with this one, like I said, I was going to cover the rest of the roof with the yellow foundations, but that meant that the elevator was going to come up right through here, which is fine. It kind of let me switch things up, and I decided to make the very top floor a little bit more open. And let's be honest, this floor has all the coolest machines, and so the less glass I have in the way, the more I can see all the cool effects. Same with the roof, I decided to just leave some big open holes, and that way the beams of these things can shoot straight up the top. And since particle accelerators are pretty tall, I figured, well, might as well just leave a hole over the top of those two. Singularity cells are the only thing that are already in the factory. I was originally sinking them down there, but if I deleted that sink at the same time as I delete the rest of the sinks, these would actually end up backing up because they received just enough and it takes long enough to get the plutonium waste made and all the way up here. So I'm going to need a second sink. So it seems silly to delete one just to have it come up here and start sinking until I delete this one. So might as well just send them up here now. But this sink is going to be dual purpose because I also need to get rid of the electromagnetic control rods until I'm ready, because those would also back up. And those ones are on a sushi belt. So I definitely need to make sure that that continues to run. And then one last sink up here for the trigons. Those come in at such a high rate, I definitely need to sink those until I'm ready. We've got the dark matter residue in the chrome pipes. And I just love the excited photonic matter in the copper pipes. As far as the decorations go, I wanted to use a lot of concrete, and so asphalt gives me a nice secondary option. It's got a great dark color and a really nice texture to it. So I just made some pillars. They're very simple, although there's more to it than it looks. These are actually made out of half foundations, but they get a little bit weird if you try to completely replace a full foundation. So if I were to place them like this, because on one side you get that texture, this is what you end up with at the corners. So instead of right at the edge, what I did is I held down control and I nudged it a half a meter in each direction. And now with this one, I'm going to nudge it a full meter. This comes out just past the normal foundation line on all three sides. And that's why. That way I could get that texture on all three sides. Because with the normal foundation, it's the normal like concrete side, and you only get the asphalt on the top of the bottom. And then to cover up all of these weird gaps, I just use beams. So there's some painted beams that run up and down, and then a whole bunch of label signs to give it that color. And then on the inside, I just filled in the gap with one painted beam. Unlike other factories where I just do gigantic windows, I felt like this was a factory where I still wanted windows, but it shouldn't look like an office building where it's just one gigantic side of windows. So, of course, more blueprints. Just using the 8-meter ramped walls, so you get the really long ramp. And then I just used a bunch of these. But I wanted a good amount of depth, so these are nudged out basically one full foundation. And then I just used the frame pillars to kind of attach it to each of the floors. So that's what the sides look like, except for when we come over to where I've got my little item elevators. This is bringing the stuff from the basement all the way up to the top floor. It's tall enough to where I needed to use the infinite lift trick to get them to be all in one. And then I just used large billboards. And the way that this was all spaced out is it was pretty much inevitable that I was going to end up running into one of my belt highways here. I just cut it off early, used some of the double ramps, and I figured, well, to even things out, this is where I should add my stairs and an entrance into the basement. And that way it's a little bit more centered. I guess if I added this and the ramps on this side, then maybe it would look a little bit more centered. That's good enough for now. I didn't do a ton of decorating for the power plants. I mean, I could have spent just hours and hours. I mean, it is a huge amount of space, so you could spend a lot of time and a lot of materials on it. I decided to keep it a little bit more minimalistic, but because of that, I decided to, add a fun feature. So now there's just a random platform so you can see the waterfall and kind of look back at everything. The spacing for these pillars got a little bit weird because I decided to make this top roof smaller, and this whole section right here is being taken up by all of these lifts. This section just was a little bit bigger, and I thought, that would be a good spot for some balconies. So now on the very top floor, obviously it's just glass foundations added on, but down here we've got some more roll-up gates. And let's be honest, because I'm using fly all the time, it's just convenient having some extra side entrances. I did the same thing with the large billboards to add a little bit more color. And then from the inside, there's a hyper tube that'll take me out here. And then it will drop down and spit me out right out here. I wanted to make sure that the miner fit in case I ever wanted to use it, so I already have the housing there. I just don't have a miner placed inside. And that's because, oh, well, of course, this is just outside of my radar tower range, but you can see if there's a miner placed on it, whether the miner is turned on or not, it'll say that it's claimed. But if there is no miner placed on the node, then it'll show this, which is unclaimed. So I guess it really doesn't matter because I don't have radar coverage here, but that's the reason I did this, just so I can make sure that I can get that coal out of here. Using more asphalt and then just alternating the up corner and the inverted up corners on here. And I always forget, but patterns can only be placed on the top side of foundations. We won't talk about how much time I wasted trying to get patterns on the bottom. It doesn't work. The hypertube just pops us out right here, so I can see all of the fuel rods going out and the waste going back into the factory. And then down here, I've just got a whole bunch of coated concrete. What else am I going to use this area for? And then just some glass foundations so you can look at the waterfall. It's a little bit of a different view than you normally get in the game, so I thought it was kind of neat. Like I said, pretty minimalistic as far as the decorations went. I added a layer of the coated concrete on the very top with some patterns for the walkway, so you can't get around, and in a bunch of places there's some glass foundations that'll take you across. This was where I had that kind of like stripe of the fix-it foundations because I kind of knew I was going to add something there, either a walkway or just some way to connect all of the power outputs. And I think they tie everything together pretty well, giving me an extra walkway and a convenient spot to run the power. This is the only, I guess, kind of unique one where the same thing didn't quite fit as well. And so I just went back to half foundations with the rounded corners and then just a good old beam right down the middle to connect everything. But the rest of them have the glass walkway that run across, and I like the way that that looks. And then with this area, I just thought it would look best if I just paved over the little bits of water that were still visible. And so it's just all asphalt out here. And I don't really need to know where the depth border is anymore, so I deleted those two. I did upgrade these belts as well, even though they only need to be Mark 1. Mark 2 does just cut down the time in half, doesn't it? I think that is finally everything. After weeks of preparation and building and mistakes and rebuilding, I can finally turn this power plant on. For the startup process, I have a total of 4 smart splitters and the sinks to delete. And then I needed to connect the belt for the sulfuric acid and introduce a few more empty canisters into the loop. Once the uranium waste gets produced, then I have a couple things to do on the second floor. And then same thing with the plutonium waste once that shows up to the top floor. I'm going to start with deleting everything but the uranium, and then I'm going to get the sulfuric acid, and then I'm going to come back and we'll send in the uranium last. With all of this selected, let's go ahead and start the stopwatch, and let's see how long it takes to get that really nice flat power graph. And here we go. And last but not least, the spicy rock. And make sure I delete that extra 10 uranium. Now that the uranium waste is showing up on the second floor, let's go ahead and get this sulfuric acid sent in. I just need a Mark 3 belt here. And I'm going to change this smart splitter back to a normal splitter. and just delete the sink. Now that the plutonium waste is showing up, I'm going to do the same thing and switch the smart splitter back to a normal splitter, and then just delete this. Now that the fixonium started, last thing to send in, the trigons. Now that's a beautiful sight right there. Look at all that steam. Well, after turning off and on a few times, looks like the fixonium is finally staying on at 100%. It'll take a few minutes for that to move all the way up to 100%. But I just checked a bunch of the plutonium ones, and these are all at 100%, which means they're creating the amount of waste that they need to create all of the fixonium fuel rods. I'm definitely going to keep an eye on it, but right now, we are looking good. The only thing is, this number is a little deceiving. Because back here at my hub, I have 2 permanent alien power augmenters, but I threw down a third one just to give me that extra little wiggle room. And if I am going to leave it on the grid, I'm going to find a better spot for it. So for now, let's go ahead and take those summer sloops back. And let's take a look at the grid. We went from 462,800 to 426. Wow, that does do quite a bit, just that one machine. Oh, that's pretty awesome though. Still, 426,600 megawatts. If you're curious what the random amounts are above the 600, the way I understand it is that when trains break, they actually regenerate some of that power. But whenever you get an influx, but it'll only be for a tick or two, it's probably because one of your trains is breaking in your world. Looks like I'm consistently using, we'll just say right about 140. That leaves me with just under 300,000 megawatts. That leaves me just under 300,000 megawatts to play with. Turns out, using more of the Mark 6 belts really does make a difference. This started up faster than a number of my recent factories. Of course, breaking the project up into smaller sections and having so many of the parts manufactured ahead of time sure does help a lot. That is going to do it for this one. Thank you so much for being here on this long journey. And a special thank you to everyone that likes, comments, shares, and hypes the videos. Any and all of it help a ton. 262,500 megawatts has been added to the power grid. With the existing turbo fuel power plant, rocket fuel power plant, and alien augmenters, my total power production is now at 426,600 megawatts. That should be enough to finish the save, I hope. I can now move on to the final projects. Before I can get to these last space elevator parts, I have a couple side projects and smaller factories I want to build. So look forward to that, and thanks for watching.